Rajiv here from Math Vibes, and today we're going to look at the May-June 2024 Paper 1 for Physics in detail. If you just care about the answers, here are the answers. Additionally, I'll also be providing a Google Drive below with the answers and the blank paper. Right, so let's begin. In the very first question, an object is removed from the ground and placed on a shelf. Which of its properties is expected to increase? Anytime we are increasing the height of an object from the ground, you are increasing its potential energy. Why is that? Now I can give you an example over here. So initially, let's just say we had a ball on the ground. Then that would have meant that the height would have been 0. So let's give the ball a mass. Let's just say the ball has a mass of 1 kg. Right, and we're gonna assume gravity is 10 because we're on it. That being said, if I wanted to calculate the potential energy for the ball at the ground, that would be potential energy. That would be equal to the mass, which in this case is 1. Gravity is 10 by the height. Now, since it's at the ground, its distance from the ground is 0, so its potential energy is 0. Now, let's just say we took the ball and we moved it up 5 meters. If I did that, my new potential energy would be equal to 1 by 10 by 5, which is equal to 50 joules. So just by increasing its height from the ground, I increased my potential energy. So anytime you're increasing height, you are increasing an object's potential energy. Another way to think about it is like this. If you take an object and you place it on a high shelf, you are increasing the likelihood of it falling down from the shelf. Part 2. The time period of a simple pendulum oscillating with a small amplitude depends on the... So what exactly is time period? Time period, let me just say we had a pendulum like this, right? The time period would be the time it would take for, let me just say for instance, you took it and you displaced it to this point. Well, time period would be the time it took for it to swing right and then come back to its rest position. That's what time period is. Now, if you have a pendulum whose length is very long, the time period is going to increase because it's going to take longer to make that movement. But if the length of the pendulum was very short, then it would be very fast, and so the time period would decrease. So the only variable here that messes with the time period is length. Question 3. When two bodies collide, momentum is conserved. This means that the total momentum before is equal to the total momentum after. That is what conserve means. Conserve means that there are no losses. Before is equal to after. A diving ball is to be used at great depths, and so its walls are made thick. The main reason for this is that water pressure increases with depth. If you recall, the pressure for a fluid is P is equal to H, which is height by density by gravity. So the deeper you go, your height is going to increase. So let me just say, for instance, you start off at a height of 1 meter, right? Let me just say the density of whatever liquid is probably like 1,000 kg per meter cube, and the gravity we on Earth, so it's 10, right? 10 ms minus 2. So if you were at 1 meter into some liquid, your pressure would be, so 1 by 1,000 by 10. Right, so that would be 10,000 pascals. Okay, let's just say we increase the height. Let me just say the height is now 7 meters. If it's now 7 meters, it's going to be equal to 7 by 1,000 by 10, which is going to be equal to 70,000 pascals. And so you can clearly see mathematically, when you increase height, you increase pressure. Logically, you could think of it like this. If you go deeper, then the amount of water pressing down on you would increase. So the pressure is obviously going to increase. Question 5. Which of the following statements about the object are true? So before I do that, I'm going to check out what graph I have. So I have a velocity time graph. The only thing I could get from a velocity time graph is either the acceleration or deceleration, or if I find the area under the graph, I can find the distance traveled. So it does not, I could never infer the position of something by a velocity time graph. So this is definitely wrong. In part 2, they're saying it has zero acceleration between T2 and T3. That would be correct, because at any given time, its velocity remains the same. So there's no acceleration. Remember, acceleration means to change your speed or change your velocity. If we're not changing any velocity, zero acceleration. Part 3, its velocity at T4 is the same as its initial velocity. That would be true. This is the initial velocity, and this over here is the velocity at T4. So it's the exact same. So my answer is going to be the one with 2, 1, 3 in it. So that's C. Question 6. Which of the following will be constant if a constant net force is applied to a body? The answer would be acceleration. Some of you all might be tempted to put velocity, but think of it like this. If you start pushing something, it's gonna start off at a low speed, and then it's gonna eventually level out, right? So the velocity would not have been constant. It's actually acceleration, and to prove that, I'm going to look at the formula. F is equal to ma. Right? If I make acceleration the subject of the formula, you'll see that acceleration is equal to force over the mass. And if I'm pushing with a constant force, my force never changes, then acceleration will not change. So if you have a constant force, acceleration will remain constant. Question 7. An object of mass m is attached to a spring balance and its weight w recorded. What will be the result if the object is taken to the moon where the gravitational field strength is less and weighed? Number 1. Mass is the amount of matter in a body or object. That never changes. So immediately, B is wrong and D is wrong. Now, if I carry an object on the moon where gravity is not so strong, then the weight would decrease, because gravity is the force that attracts an object to the center of its core. So if you go on the moon, then the gravitational field strength is going to be less. So the object will experience a lesser force pulling it to the center of the moon, as if it was on it. So the answer is A, right? The mass will remain the same, but the weight will decrease. Item 8 refers to the following diagram, which shows a non-uniform bar pivoted at P. W indicates the weight of the bar, and forces F1 and F2 are applied at the positions shown. The sum of the clockwise moments about P equals, alright, so they want me to find clockwise moments. So anytime you're dealing with a question like this where it's about moments, you're looking at turning force. To calculate the turning force, it's always equal to the force, either the upwards or the downwards force, multiplied by the perpendicular distance from the pivot. Guys, from the pivot. First things first, we need to figure out where's the clockwise and where's the anti-clockwise. Well, we only care about the clockwise, right? So this is the pivot here, right? If I take this non-uniform bar and I pull it upwards, it's going to turn in this manner. And this looks like that clearly looks like a clockwise rotation, right? So if you apply an upwards force, if you take the bar and you pull it upwards, it's going to generate a clockwise moment. So I have a clockwise moment here, right? The weight over here, if I were to take the bar and pull it down here, the bar would now be in this position, right? And this looks like it's rotating in it has an anti-clockwise manner. So I'm not going to consider that turning force. Let's look at F2. So this is the pivot here. If I apply a downwards force, let's see how the non-uniform bar is going to rotate. Let me just say I push this down. This is how the non-uniform bar is going to look. So it looks as though it's rotating in this is a clockwise manner, right? So we have the other clockwise moment here, right? This also is a clockwise moment. So if I want to figure out the turning force for F1, it's going to be the force, so F1 multiplied by that force, its distance from the pivot. So that's the distance from the pivot is D1. So that's going to be F1 by D1, and that's not the only clockwise moment. There's also F2, right? And F2 is D2 meters away from the pivot. So that's going to be F1 D1 plus F2 D2. So my answer is D. Question 9. A boy measured the height of a laboratory table Which of the following measurements is most likely the correct one? So the answer that makes the most sense here is C, right? 0.00895 meters would make sense. The table is not for ants. 0.0895 meters is, I doubt the table is for like a baby. And D, I doubt the table is for a Titan. If all you watch Attack on Titan, drop a 1 in the chat. The only one that makes sense is 0.895 meters, which is very close to a meter. Most tables are situated about this height, right? 1 meters. In question 10, we have a vernier caliper. Which of the following readings is shown on the scale above? So in a vernier caliper, we have the main scale on top and the vernier scale in the bottom. So in this scale, let's count the amount of increments we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. So between 12 and 13, right, that's 1 centimeters. And so in between that, you have 0.1 over centimeters. So that's what one of the increments mean, 0.1 centimeters. On the vernier scale, that'll tell us the reading to 0.01. Right, so in this situation, 0 starts over here on the vernier scale. Then this is 1, this is 2, this is 3, this is 4, and that's 5. So when you're reading a vernier caliper, you look at the main scale first, right? So the main scale stops at 12.2. And now, so like on top, it's 12.2. And to figure out the answer on the vernier scale, we're going to read off at the bottom. So 0, 1, 2, 3, 4, 5, 6. You notice that at this point, the vernier scale aligns with the main scale that you really actually want to take. So this reading would correspond to 0.06 centimeters. So if I combine the 12.2 and the 0.06 centimeters, I'm going to get 12.26 centimeters. And that's my answer. So that's how you read a vernier caliper. Right? Let's continue. Question 11. Which of the following features must be present in a stable, well-designed racing car? In a racing car, you don't want it to topple over, so you need a low center of gravity. Why we need a sunroof? Right? For the people to get shoot out of. Question 12. The unit for momentum is, so the formula for momentum is mass times velocity. The SI unit for mass is kg. And the SI unit for velocity, that's meters per second, or ms minus 1. So your unit is kg ms minus 1, so that's B. That's what momentum is. 13. Question 13. In an experiment to locate the center of gravity of a sheet of cardboard, a plumb line string with a small mass on the end is used. The plumb line is used to C. It's used to show which points are vertically below the pivot. So typically what would happen is you'd have a retort stand and you'd have a pin here. And on the pin, you would attach the irregular shape, right? And what you would do is you would take a string with a mass, and that would define the plumb line. So the plumb line, it tells you the vertical point right below the pivot. Question 14. A bubble of gas rises to the surface of a soft drink. The reason this is happening is because the upthrust on the bubble, the upthrust is more than the weight of the bubble. So weight always acts downwards. So let me just say the weight is 1 Newton and the upthrust is 3 newtons. What's going to happen is if you take away 1 from 3, you're still going to remain with 2 newtons, and that's going to push upwards. So it's going to cause the bubble to rise. And so what's going on is the upthrust on the bubble is greater than the weight of the bubble. And so the option that best captures that is B. So B is the correct answer. Upthrust on the bubble is greater than the weight of the bubble. Question 15. Given that force is equal to mass times acceleration, the unit of force could be written as, so mass is measured in kg and acceleration is measured in ms minus 2. So the answer is D. Question 16. Which of the following pairs consists of fundamental quantities? So I want you all to think of fundamental quantities as quantities that just exist. There are no formulas for it. They just exist. So mass and weight, that would be wrong, right? Weight is actually mass by gravity. So that's not correct. Mass and length. Now we're talking. It don't really have a formula for mass and it don't really have a formula for length. They just exist, right? They are fundamental. You would use that to describe basic quantities, right? Time and current are also fundamental quantities. So you're looking at 2 and 3. So the answer is D. Question 17. As the temperature of a liquid rises, the answer is C. The kinetic energy of its molecules increases. So in any substance, if you apply heat, the molecules are gonna gain kinetic energy, and when they gain kinetic energy, they're gonna start to vibrate and move about. If they are vibrating and moving about, then the forces between the molecules are actually gonna decrease. And if they start to decrease and the molecules start to spread apart, then they're gonna take up more volume. And if it's taking up more volume, then the density will actually decrease. So A and B is very wrong. Now D talks about the pressure, and we should know by now that the pressure of a liquid mainly has to do with the height, right? The depth or the height. They're the same thing. Question 18. A metal of mass M requires energy E to raise its temperature from T1 to T2. The specific heat capacity of the metal will be given by, right? So the formula we're going to think about here is E is equal to mc delta theta because there's a change in temperature. So delta theta just means T2 minus T1. So I'm going to make that substitution. So I want to find for C. If I want to find for C, I would have to divide both sides by M by T2 minus T1. I'm going to divide both sides by this. And the reason I'm doing this is so that on the right hand side I'll end up with C alone. That being said, C is going to be equal to E all over M by T2 minus T1. So the option that corresponds to that is C. Now, without even doing all of this, you could have figured out your answer, right? If we're talking about specific heat capacity, there's a change in temperature. That's always T2 minus T1. This one doesn't have T1 in it, so that's wrong immediately. This one is saying T1 minus T2, which is very wrong. It has to be T2 minus T1, right? This one has T2 minus T1, but they messed up the mass, right? If you have E is equal to mc delta theta, and you have to find for C, obviously you'd have to divide by M. So M cannot be in the numerator. So this is definitely wrong as well. So C is the only correct answer. Question 19. Which of the following ranges of temperature is most suitable for a clinical thermometer? Right? If you're a human, your normal range of temperatures should be between like 35 to 44. Right? So that's the answer there. Unless he is like Elsa or something. Right? Question 20. So in question 20, we have, it shows a piece of ice wrapped in copper gauze and submerged in a glass test tube of water. So the water, when heated at the top, boils long before the ice is melted. The main reason for this is because water is a poor conductor of heat. Think of it like this, guys. Even if I were to change this glass to like copper, the copper would absorb heat very fast because obviously it's a metal and the top would get hot, but it would still take a while for this to heat up because the water is not doing a very good job of transferring the heat from the flame to the ice. So that's why the water at the top boils long before the ice is melted. Question 21. The specific latent heat of fusion of water is 340 kilojoules per kg. This means that when 10 kg of water freezes, what happens? So I would like you all to pay close attention to this, right? It says 340 kilojoules per kg. So for every 1 kg is equal to 340 kilojoules. That's what it means. So if I wanted to find for 10, I'll just multiply by 10 on both sides. So 10 kg would be equal to 340 by 10, which is 3,400 kilojoules. So I'm looking for the answer with 3,400 kilojoules in it, right? And you have to be careful here. If water freezes, then heat is given out, right? Heat is given out because it's freezing. It's dumping all the heat to the atmosphere. So it's C. C is the answer. 3,400 kilojoules of heat is given out. I would not say absorbed because If you absorb heat, then you're getting hotter. We want to freeze something here, so the heat has to be given out. 22. An electric kettle full of water is plugged into the mains. The major process by which heat travels through the water is convection. When you heat water in a pan, the water that will be hotter would obviously be the water at the bottom of the pan. So that water at the bottom is going to become really hot, and hot fluids rise. And so that's going to go up to the top. And if that goes up to the top, the cooler water would now reach to the bottom, that would heat up, and so the cycle would continue until it creates convection currents inside the pan. And this is what convection currents look like. This is what it looks like. Right, so you have the hot water going up to the top and the cool water being pushed to the bottom. Right? And when this water becomes hot, then it'll go back up to the top, and the cooler water at the top will go back to the bottom, and it will just keep on cycling. Which of the following materials is both a good absorber and a good emitter of thermal heat energy? So the answer here is D. The reason why I'm saying D is because metals are very good absorbers of heat, and they're also good emitters. And the same thing for black surfaces. Black surfaces are the best absorbers of heat, and because they can absorb so much thermal energy, a good bit of that is also emitted. So the answer is D. 24. When heating a substance, a point is reached where no further change in temperature is observed. The most likely reason for this is that the substance is changing state. I would like you all to think about latent heat of vaporization and latent heat of fusion. When we're doing those questions, you realize that there's a point where you need energy, not to change temperature, but to change state. The reason for this is because the molecular structure actually needs to change when changing state, and that requires energy in and of itself. 25. To check the upper fixed point on a thermometer on the Celsius scale, the thermometer is placed in steam above boiling water at atmospheric pressure. If you all recall, the upper fixed point is at 100 degrees Celsius, right? And steam is at 100 degrees Celsius, especially if we are talking about atmospheric pressure. So that's how you would check for the upper fixed point. Who was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy? Guys, if I had to take a shot for the amount of times I see energy in this question, I'd be drunk. So anytime you see energy, you should be thinking, joules. It should be a giveaway. Although, based on the joke I just saw make, a Rumford sounded like a good answer. Question 27. Two types of radiation, L and R, fall on a woman's left and right hand, respectively. Her left hand feels hot, but does not become tanned. Okay, so they're saying that her left hand feels hot. Anytime we're talking about heat energy, we're talking about infrared rays, because infrared radiation and infrared rays, they actually carry most of the heat energy. Now the other hand does not feel hot, but it eventually becomes tanned. So if it becomes tanned, we're talking about cell damage there. Think about it. When you go in the pharmacy to buy sunscreen, doesn't the sunscreen protect you against being tanned? And the reason for that is because sunscreen protects you from the ultraviolet rays. So your answer is D. Right? So L is infrared and R is ultraviolet. Which of the following statements about evaporation is false? Okay, so the immediate answer I'm seeing here is C. They're saying that evaporation occurs at room temperature only. Now, evaporation can happen at any temperature. Think about it. Heck, you could spill something in the fridge, and we could all agree that the fridge is not hot. And if you leave it for like a couple of weeks, that patch of water that was spilled would probably not be there. So evaporation could actually happen at any temperature. So that's a lie. C is a lie. So item 29 refers to the following diagram, which shows a longitudinal wave train produced on a slinky. So notice they're talking about longitudinal wave train. So this is a longitudinal wave. Now longitudinal waves they have compressions and rarefactions. So this over here, this is an example of compressions, and these over here are examples of rarefactions when the slinky spreads out. So when we're talking about wavelength, wavelength would be the distance between two successive compressions or two successive rarefactions. So this is an example of two successive compressions. So like A to C would be a possible answer, right? C to E would be a possible answer. Heck, B to D would be a possible answer because those are two successive rarefactions. So in the options, you see that C to E is listed, so C to E is the answer. Which of the following statements is true of diverging lens? A divergent lens looks like this. So let's see any truths here. It is thinner at the center than at its edge. Oh, so we found the answer immediately. So the answer is A. Item 31 refers to the following diagram, which shows an object in front of a plane mirror. Anytime you have an object, it'll always be reflected in the mirror. So that's my answer. So my answer would be B. Question 32. Which of the following statements about sound is not correct? Sound travels, that's true. Sound does not travel, that is true. Sound is transmitted as, this is a lie. We know that sound actually is a longitudinal wave. So that's a lie, right? 33. A ray of white light enters a transparent glass prism. In which of the following diagrams is a dispersion of light correctly illustrated? First things first, we're looking for Roy G. Biv. Any of the options that does not have Roy G. Biv is automatically wrong. So this has Roy G. Biv, so it could be a possible answer. B has Roy G. Biv, but that's wrong. C is definitely wrong, and D is definitely wrong. Now, light would not split at the outside. It would split at the inside of the glass prism. So the only answer here that makes sense and fits the Roy G. Biv convention is E. So A is the answer. Which of the following properties is true of both light waves and sound waves? They are electromagnetic waves? No. Electromagnetic waves are transverse waves, and that would only apply to light waves. They are longitudinal waves? No. Only sound waves are longitudinal waves. They may be transmitted through a vacuum. That's a lie. Lie. Right? Because sound waves can't be propagated in a medium like space, because there's no particles to propagate. So it can't be C. So D is the answer. Both could undergo refraction. Right? Remember, refraction is what happens when you go from one medium to another. Right? Both light waves and sound waves would experience a shift because they would travel at different speeds in different mediums. Light waves get slowed down when it has to travel in a denser medium, whereas sound waves the speed actually increases when it has to pass through a denser medium. So it's actually the opposite. So both of them undergo refraction in that sense. 35 refers to the following diagram in which two coherent light sources produce an interference pattern on a screen of bright and dark fringes. So bright fringes would happen when the waveform is in phase, right? That's called constructive interference. And where there's dark fringes, the waveforms are out of phase, and so they would result in destructive interference. So they would cancel off each other. So the reason for the formation of bright fringes, I think I just answered that, would be that all the crests and troughs are in phase along these points. That's the answer. So if you all are wondering what a crest is and what a trough is, a crest is just basically the top of a waveform, and the trough is the bottom of a waveform. That's what it is. 36. A ray of light leaves the air and enters glass of refractive index 1.5. If the angle of incidence is 37 degrees, what is the sine of the angle of refraction? So the formula we have to use here is N is equal to sine I over sine R. So what is the refractive index here? The refractive index here is 1.5. What is the angle of incidence? It's 37. And that's over sine R. So to find for sine R, I could swap the positions of the 1.5 on the sine R, and so sine R is going to be sine 37 all over 1.5. So my answer is D. 37. Which of the following objects can detect X-rays? So the answer is photographic film. So X-rays actually are transverse waves and they belong in the EM spectrum. So think about it, guys. Photographic film could be sensitized by visible light, and then visible light is also on the EM spectrum, so it makes sense for X-rays to also affect it. 38. A note from a drum is louder when it is struck harder because the sound waves produce a greater amplitude. So get this from now, guys. If we're talking about loudness has to do with the amplitude of a waveform. That's basically how high or low the waveform goes, right? And if we talk about frequency, we're talking about pitch of the waveform, whether it's high-pitched or low-pitched. Right, so loudness is amplitude and frequency is pitch. Keep that in mind. 39. Which of the following wave phenomena are exhibited by sound waves? The answer is all three. The answer is D. Which of the following diagrams represents the electric field existing between two oppositely charged point charges? So if we're talking about oppositely charged, they're going to be attracted to each other. So you all should know that when we're dealing with a positively charged particle, the field lines are going to extend outwards. And if we're dealing with a negatively charged particle, the field lines are going to come inwards. And so our answer, we're looking for the positively charged side to be going outwards and the negatively charged side to be going inwards. So the only option that corresponds to that would be A. (41) Which of the following symbols represents the AND gate? So the AND gate is represented by B, right? A is a NOT gate, C is a OR gate, and D is a NAND gate. 42. Which of the following relationships between electrical quantities is correct? So the only one here that's correct is C, right? Part A is a butchered version of P is equal to VI, right? Part B is a butchered version of V is equal to IR, and part D is a butchered form of E is equal to VI by T. So, 43. Which device allows one circuit to switch another circuit on or off without any contact between them? We're talking about a magnetic relay. So in a magnetic relay, basically, once you supply power to the coil side of the magnetic relay, it causes a magnetic field to be developed, and this causes the latch on the secondary side of the circuit to be attracted to the magnetic field, and that causes the latch to be closed, and that completes the circuit in the secondary side. And that is how you could switch another circuit on or off without any direct contact between them. Question 44. A glass rod is rubbed with a piece of silk and is positively charged. The glass rod became charged by losing electrons. So when you rub a glass rod on a piece of silk, what happens is some of the valence electrons that are weak actually get transferred to the silk. So the glass rod became charged by losing electrons, right? Notice it said and is positively charged. So to become positively charged, you have to lose electrons. 45. When an excessive current passes through a fuse, which of the following is the sequence of events? So what exactly is a fuse? A fuse is just basically, so you have your wire here, and inside the fuse you'd have a very thin wire, right? If the current rating is surpassed, what happens is the wire on the inside heats up, it melts, and it breaks circuit. So the answer that corresponds to that is B, right? So 45B. So the wire gets hot, the wire melts, and the current is cut off. 46. Which of the following current time graphs best represents a DC current? Now, a DC current stands for direct current, and basically what that means is or the direction of the current never changes. So if it's positive, it always remains positive. If it's negative, it always remains negative. So the answer for this is actually A. This is actually what a DC supply would look like immediately after a full wave rectifier, before a capacitor is added on to smoothen out the ripple. B is definitely wrong because the current is alternating from positive to negative. C is wrong as well because it's alternating from a positive to a negative. D is wrong as well because it alternates from a positive current to a negative current. Right. 47. Appropriate labels for device W and input X are. So let's observe. So we're seeing approximately 3 turns in the primary and 4 turns in the secondary. Since we have more turns in the secondary, this is definitely a step-up transformer. So that makes A and B void. And you all should know that a transformer only works with AC input. So the answer is C. And the reason why more turns increases the voltage is because, according to Faraday's law, the induced EMF is directly proportional to the rate of change of magnetic flux. So by you adding more turns, when you supply power to the primary coil, more wire is going to cut that magnetic field, and so the induced EMF in the secondary is going to be more. Right? So anytime you have more turns, that means you're stepping up the voltage. The voltage is going to become larger. 48. What is the period of the current? So what exactly is period? Period is the time it takes for one full oscillation. So this is what I mean by one full oscillation. Then we have another full oscillation here. And well, this is looking like a quarter of oscillation. So we have 2 full oscillations. So the time period would be from the start to the end of one full oscillation, which is 4 seconds in this case. So it's 4 seconds. An ideal transformer has a primary to secondary turns ratio of 1 to 3. An alternating potential difference of 200 volts is applied to the primary coil, and a resistance of 200 ohms attached to the secondary coil. What is the current in the secondary circuit? So, according to the turns ratio here, for every 1 turn we have in the primary, we have 3 turns in the secondary. So what that means is my turns ratio is going to be 3. And what that means is whatever voltage I supply on the input is going to be times by 3. So let me just explain that here. So for every turn we have in the primary, we have 3 turns on the secondary. So I just want you all to recall, remember this formula, Ns over Np, right? Ns over Np is equal to Vs over Vp. And so in this instance, the number of turns in the secondary, we could take it as 3. And the number of turns in the primary, we could take it as 1. So that's going to be 3 over 1. So 3 over 1 is equal to Vs over Vp. And if you cross multiply, you'll see that 3 by Vp, so 3 Vp is actually equal to 1 by Vs. So to get the voltage in the secondary, we have to multiply the voltage in the primary by 3. So if an alternating potential difference of 200 volts is applied to the primary, then the voltage in the secondary is going to be 3 times that. So the voltage in the secondary is going to be 3 times 200, which is equal to 600 volts. So on the secondary side, we also have our resistor. The resistor here is 200 ohms, and we know that the potential difference across that is 600 volts. So if I want to find current, remember V is equal to IR. And if I make I the subject, I would be equal to V over R. So my voltage is 600 and my resistance is 200. So 200 into 600 is 3. So my answer is 3 amps. That's it. 50. Which of the following combinations of ammeter characteristics is correct? So when we're hooking up our ammeter in a circuit, let me just give you all an example. So this is our battery cell here, positive, negative. If I wanted to measure the current, and I'm going to add in a resistor here, why not? Because to draw current, I actually need resistance. So I have a resistor here, and I would hook up my ammeter in this manner, and it has to be hooked up in series. Why does an ammeter have to be hooked up in series in a circuit? Well, the reason for that is because if I want to measure current, logically, doesn't it make sense that the current has to pass through the ammeter so I can take a reading? And well, if the current has to pass through the ammeter, if I'm putting in an ammeter in the circuit, I don't want the ammeter to change anything about the circuit. So ideally, the current should just pass straight through this ammeter. So the ammeter should have a resistance of 0, ideally. So we hook up our ammeter in series in a circuit, and we should have a very, very low resistance. So the answer is B. And why is that? It has to be in series so the current could flow through it, and the resistance has to be very low so that it doesn't affect the circuits in any way. We don't want to add any extra resistance to the circuit. We just want the current to pass straight through the ammeter and do what it was supposed to. We only want to measure the current, not interfere with the circuit. Item 51. This refers to the following diagram, which shows two resistors R1 of 6 ohms and R2 of 4 ohms in parallel. So I'll show you all the logical approach and then the physics approach. So current always takes path of least resistance. So if 1.8 amps is flowing through the 4 ohm resistor, it makes sense that less current would pass through the 6 ohm resistor. So the answer is obviously 1.2 amps. Now, let me show you the physics. Now, anytime we have a parallel circuit, that means that the voltage across both of the resistors have to be the same. Now, notice that I have the current and I have the resistance. If I have the current and the resistance, I can find the voltage drop across this particular resistor. So recall, V is equal to IR. My current is 1.8. My resistance is 4. And I believe 4 by 1.8 equal to 7.2 volts. And since these two resistors are in parallel, the voltage drop across both of them is going to be 7.2 volts. So if I know the voltage drop across both of them is 7.2 volts, and I know the resistance for R1, I can figure out the current. So I is going to be equal to V over R. My voltage is 7.2 volts across both of the resistors because they are in parallel, and that's going to be over the resistance for R1, which is 6. So 7.2 divided by 6 is 1.2 amps, and that's how you do it using physics. 52. The best material for the core of an electromagnet is soft iron, to be specific. I think they meant to put soft iron, right? The reason for that is because soft iron has the highest magnetic permeability. What does that mean? That means it allows the magnetic fields to pass through it the easiest, right? That's one. And the other reason is that it has the lowest hysteresis loss. Anybody here that going on to do power systems in electrical engineering, I'll go drop a 1 in chat. Maybe all you might see what I'm talking about. Question 53. Given that the potential difference across the lamp in the circuit is 4 volts, what is the potential difference across A? So the answer for this is quite simple, is 8. Why is this 8? I'll explain something. Right. So I'm doing electrical engineering, and so I'd like to impart some of my knowledge. So in any circuit, the sum of the source voltage, well in this case it's just 12 volts, has to be equal to the sum of the voltage drops in the circuit. So I have a voltage drop over here, and if 4 volts is being lost across this, then the other 8 volts would have to be dropped across this. Makes sense, because if I'm supplying 12, right, energy has to be conserved, and so I have to be using up that 12 somewhere in my circuit. So my answer is going to be 12 minus 4, which gives me 8. So my answer is B, 53B. 54. Which of the following describes two properties of an alpha particle? So for those who don't know, an alpha particle exists as a helium nucleus in nature, which is 4,2He. So that would be positively charged, and it would be not very penetrating. It's actually the least penetrating. Right after that is beta, and after beta is gamma. Gamma is the most dangerous. 55. Isotopes of an element differ from each other in that they have different numbers of neutrons. That's the only difference between them. I could give you an example, right? Let's just say we have carbon 12 here and we have carbon 14. Both of them would have 6 as a number of protons, but the only difference would be the number of neutrons. So just to give a quick recap, the number on top is actually the mass number. So the number on top is the mass number, and the mass number tells you the number of protons plus neutrons. That's what the mass number tells you. And the number in the bottom is the atomic number. Right? And the atomic number tells you the number of protons in an element. So in this instance, 12 minus 6 is 6. So this carbon has 6 neutrons, right? And in this instance, 14 minus 6 is 8. So this carbon has 8 neutrons. So the only difference in an isotope is the number of neutrons, specifically the mass number. So look out for that. Which of the following graphs shows how the activity of a radioactive source varies with time? So when we're talking about radioactive source, we're talking about decay, right? And the decay curve for radioactive sources is always a exponential decay graph. Over here we have a linear graph, that can't be true. We have another linear graph, that can't be true. Over here, that look like, I don't even know what that is. Right, so our answer is clearly D. This shows an exponential decay. And this should look very familiar, because all the graphs you would have to deal with up to this point, you would have had to find half-life for graphs looking like this. So you'd find the half-life like this, right, then like this. It should bring back memories. Right, so just remember that, right? All radioactive decay is given by an exponential decay. What that means that it starts off at a high point and it gradually decreases until it approaches 0, right? Which of the following scientists formulated the equation E is equal to mc squared? We're talking about the dog, Albert Einstein, right? Albert Einstein is a man. 58. Which of the following statements about radioactive decay are correct? Number 1, it is dependent on conditions external to the nucleus. That's a lie. Actually, the main reason why radioactive decay does happen is because if an element is unstable. And how do we know that? Well, to figure out if an element is unstable, we actually look at the nuclei, right? So for an element to be stable, the proton to neutron ratio should ideally be 1:1. If this is not the case, it might undergo radioactive decay in hopes of becoming more stable. So number 1 is wrong. Part 2, it is a random process. That's correct. Part 3, it is due to changes in the nuclei of atoms. That's correct. So you understand, part 3 would directly conflict with part 1, because part 1 says that it is dependent on external conditions, whereas part 3 says it is due to changes in the nuclei. So your answer is 2 and 3. So that's C. 59. Which of the following statements about radioisotopes is true? Right, so sometimes they are used in medicine. That's it. An example would be to treat thyroid cancer. I think iodine is used for that. I could check that for me. 60. An isotope of uranium. So we have uranium, which is 23492U. Right? Changes to thorium, which is 23090TH. This is an example of what? So immediately the answer is alpha decay, right? But why? I want you to observe something. In any equation, the left-hand side must be equal to the right-hand side. So if we started off with 234 and now we are at 230, that means we would have lost 4 from our mass number. Okay, 4. And let's look at the atomic number now. So we started off with 92 and now we're at 90. So where did the 2 go? Right, so we end up with something that looks like 42. And immediately you should be seeing that this is a alpha emission, right? So to end up with thorium, the uranium had to emit an alpha particle, and that's how you ended up with thorium, right? So that was it. If you found this video benefited you, drop a 1 in the chat. Based on the feedback, I'll continue to do in-depth solutions. If I don't really get much feedback, I might think about it. So yeah, guys, best of luck studying. Atomic mass.